Okay, so this is going to be on the homework portion of section 7.1. And I'm going to do a few selected problems from students that requested these problems. So I'm going to be doing number 7, 11, 15, and then 75. Okay. So let's start with number 7. So number 7, you're not asked to prove an equation. So you're given an expression, which is a tangent square x minus secant square x, and you're being asked to just simplify. And they gave you a hint. Write everything in terms of sine and cosine and see if you can somehow make this look a lot simpler. Okay, so we're going to take their advice. So that's going to be our first step. So let me just kind of write what the direction is. Right in terms of sine x and cosine x, and then simplify. Okay, so here is our first step. Tangent is sine over cosine, so it's really sine over cosine square. I'm going to be technical for my very first problem, but for the next problem, number 11, I'm going to not do this. But for this very first problem, I'll get a little bit technical. So tangent x in this case is sine of x over cosine of x, and it's tangent x square, so the whole thing is being square. Secant square x, which is really secant x, the whole thing square, so secant x square, but secant is 1 over cosine. Okay. All right, well, if you square a fraction, then it's going to be the top square and the bottom square. So it'll be sine square, sine x square. It's going to be sine of x and the whole thing square, but we're not going to write the whole thing square. We're going to put the square right next to the sine, which means the same thing. And it'll be cosine of x square, and you can write that as cosine square of x. It means the same thing. 1 square is a 1, and this guy is just cosine square of x. And here I'm not trying to prove anything. I'm just starting out with an expression, and I'm applying some identities to see where we'll end up at. There's really no wrong answer, but if you do everything correctly, you should get something that's pretty nice. In this case, you'll see that we'll get a -1. Okay. All right, well, you have 2 fractions. You can combine that into 1 fraction. Add or subtract fraction, you need the denominator to be the same, and we do have the same denominator, so this is just going to be cosine square in the bottom, but it'll be sine square x minus 1. Okay. So after doing trig for a while, you'll see things. So I see here that sine square x minus 1 is not quite what I want. I actually want 1 minus sine square, because I know by the Pythagorean identity, sine square x plus cosine square x is 1, And so if I move that sine square over, then I see that cosine square x is 1 minus sine square x, okay? So if I can somehow get this to become 1 minus sine square, I can apply this identity. You can't just switch the second term to be the first term when the operation is subtraction. So what we have to do here is do a trade-off. You can do it. It is equivalent to 1 minus sine square x, but there's going to be an extra negative in front. So you can put a negative in front, put a parenthesis around that, or really just put a negative in front of the whole fraction. And that just means the same thing. Okay. All right, so I get to flip the sine square with a 1, but then I need to add in this extra negative. All right, so now that 1 minus sine square x is the same thing as cosine square x. The bottom is also cosine square x. Well, cosine square x over cosine square x is going to become a 1. So this expression, after converting it to be sine and cosine, applying the Pythagorean identity, is simply just 1. And this would be true for any x. So if I were to evaluate this with x being 30 degrees, 45 degrees, 60 degrees, or you can use a radian, any angle would make this into a negative 1. Okay, so that's number 7. All right, next problem would be number 11. And it's the same type of problem. We're going to start with an expression. And we're going to rewrite this in terms of sine and cosine and simplify. There's really no wrong answer depending on how you want to go about adding or subtracting these guys together. But if you do it correctly, you should end up with tangent theta. Okay. All right. So the very first step, rewrite this in terms of sine and cosine. Secant is the same thing as 1 over cosine. And cosine is just cosine. And sine is just sine. So now we have this complex fraction. You have a fraction within a fraction. And we want to somehow simplify this. There's a lot of ways to really approach this problem. And there's no wrong way. So I'll show you one way. And so we're going to really focus on this bigger fraction, this main fraction here. And so this is going to be my numerator. This sine theta is going to be my denominator. And I get to resolve this complex fraction. I get to get rid of this minor fraction if I were to multiply the whole top by cosine theta. Okay. Well, if you multiply the top by cosine theta, you have to multiply the bottom by cosine theta as well. And this is just balancing out the fraction. Anything you multiply on top, you have to multiply the bottom by the same thing. So I can multiply anything I want on top as long as I multiply the same thing on the bottom. But I do have a purpose for this cosine theta. If I multiply the top by cosine theta, that means that 1 over cosine theta will be multiplied by cosine theta, right? So you're going to distribute. So this guy is going to be multiplied with that first term, but also the second term. So minus, and this is the cosine theta inside, but you'll multiply by another cosine theta, and that's this guy. And it's all divided by sine theta times cosine theta. Okay. All right. 1 over cosine times cosine, well, that will cancel, and you get just a 1. Cosine times cosine, so here's subtraction. Cosine times cosine is cosine square, so cosine theta square, but we'll put the square on top of that cosine. So it's 1 minus cosine square theta. And the bottom is sine theta times cosine theta. And we've seen this before. So you'll see that once you see something before, you can just reuse it again. 1 minus cosine square theta is the same thing as sine square theta. Okay? All right, so I get to replace that 1 minus cosine square theta with sine square theta. And the bottom is sine theta times cosine theta. And we have 1 sine on the bottom. We have 2 sines on top, sine square on top. We have a sine on the bottom. One of them will cancel out. That leaves just 1 sine on top. And this cosine to be on the bottom. And what is sine theta over cosine theta? What's another name for it? Tangent theta. Okay, and that is it. This is our answer for number 11. Okay. All right. So the next problem will be number 15. And so we're going to start with an expression. And it's not x this time, it's t. So sine of t plus tangent of t, and it's all divided by tangent of t. You're not asked to prove anything. We just want to simplify. That means rewrite this in a more simpler form. And again, there's a lot of ways to approach this. There's the more efficient method. There's the less efficient method. But if you're just beginning to learn how to deal with trig identities, I would recommend just to keep it simple and convert everything to be sine and cosine. So that's what we're going to do. If I have no clue on what to do with this, there is no identity, there's no apparent identity that will allow me to do something with this sine t plus tangent t. So I'm stuck, right? You can't simply just cancel out the sine t in this case. That does not work. So let me remind you guys that if I have a times b over b, then you can cancel that out and it will just be b, a, right? That's under multiplication. If you divide, so they do just kind of cancel each other out. Multiply and divide will just cancel out the b's. But if you have a plus b divided by b, you cannot do that. It is not equal to a. So this is wrong. Okay. So what do we have here? Sine of t plus tangent of t divided by tangent of t. So you cannot cancel out that tangent of t. We have to just rewrite everything to be sine and cosine and then figure out from there. So that's what I'm going to do. Sine of t plus, and this is sine of t divided by cosine of t, and it's all divided by sine of t divided by cosine of t. And let's figure this out. So what should be the next step? Maybe yours would be different than mine. And it's not to say that my step is better than yours. It's just really on a matter of taste. So for me, I see a complex fraction. I see a fraction within a fraction, and I always want to get rid of this complex fraction. And so if I multiply the whole top by cosine, I'll get rid of this minor fraction. That means I have to multiply the bottom by cosine as well. But if you look at the bottom, multiplying by cosine would also get rid of this minor fraction. So actually multiplying by cosine on top and bottom is actually a really good idea. So we're going to multiply top and bottom by cosine. That's what I'm going to do. Right? If you multiply top by cosine, multiply bottom by cosine, and that is really going to resolve this complex fraction issue. So cosine is going to be multiplied with the first guy, and it will be multiplied with the second guy as well. So, sorry, that should be t, not theta, right? So everything is in terms of t. So we don't want to introduce a new variable if we don't have to. So this is sine of t multiplied with cosine of t. And here, let me save some time here by just simply canceling out the t. So if you have sine t over cosine t and you multiply that by cosine t, well, that'll cancel out the cosine, and you're left with just sine of t. And the bottom, the cosine will cancel, and you're left with just sine of t. And again, you can't do this, you can't do that. The only way to cancel out a factor on top and bottom is if it's a factor of the whole thing. So this sine t right now is just a factor of cosine t. It is not a factor of the whole thing, but it turns out it is. So I can actually factor out the sine from both terms on top. And for the first term, I'm left with cosine t. For the second term, if you have sine t and you factor out sine t, it is not 0. It is a 1. Because sine t times 1 is sine t. Okay? So once I factor out that sine t, you see here that sine t is indeed a factor of the whole term on top, and this is just one term. And here I can now cancel out this sine t. So once I cancel that sine t, you're left with just cosine t plus 1. Okay? And that's it. You can rewrite this as a 1 plus cosine t. All right, so that's number 15. Last problem, 75. This is a hard problem. You're being asked to prove the trig identity sine cube x plus cosine cube x divided by sine x plus cosine of x, and somehow this is equal to 1 minus sine of x cosine of x. All right, if I want to prove this, I have to start on one side and apply a whole bunch of identities to get to the other side. It seems like the right side looks a lot more simplified than the left side. The left side, you have cubics, the sum of cubics divided by sine x plus cosine x, whereas the right side is simply just 1 minus sine x cosine x. So this is the simplified version of this guy. So I'm going to start on the left side, left-hand side, which is going to be sine cubic x plus cosine cubic x divided by sine x plus cosine x. And this is where you have to remember back in Math 21, pre-calculus, the first part, where you learn that the sum of cubics. So recall, so let me write that over here. If you have a to the third, or a cubed, plus b cubed, this is equivalent to a plus b, multiply with a squared minus minus ab plus b squared. Okay. Can you see that? Let me just, that's really bad. Let me just rewrite it. So a to the third plus b to the third is equal to a plus b multiplied with a squared minus ab plus b squared. Okay. All right, so what's my a and what is my b? My a will be sine x and my b will be cosine x. So wherever a is, I'll write that as sine x. Wherever b is, I'll write that as cosine x. It looks like I don't have enough room here. I'm not going to try to attempt to fit it in. So let me just move it to the next line. So it'll be a plus b. So what's a? Sine x. And what is b? Cosine x. Multiply by a squared. So a will be sine x. Sine x squared is sine square x, right? Minus a times b. Well, that's sine x times cosine x. Okay. I accidentally wrote cosine first, so I'll stick with that. And this is b squared, which is cosine x squared. Okay, and the bottom is the same. It's going to be sine x plus cosine x. There's really no parenthesis around this guy, but you can view this as really the whole thing multiplied by what? By 1. And so now it is a factor. It's a factor of the bottom and the top. You get to cancel that out. And so what's remaining on top? This sine square x minus cosine x sine x plus cosine square x. It's all divided by 1. And if you divide by 1, you get back the same thing. So it's going to be sine square x minus, yeah, this is correct. I'll just keep the cosine in front. So it's cosine x times sine x plus cosine square x. Really, I think it's by habit that I usually write the sine in front of the cosine for whatever reason. This is definitely correct. There's nothing wrong with this. But if you look in the book, it's probably written like this. And it's really by convention. So for whatever reason, we like to write our sine before our cosine, even though C comes before S. Okay. And, well, we're not done yet, right? So we're not done. Sorry, guys. So here we're going to move this cosine square in front. So I'm going to move it in front, and that's just an algebraic step. So this is going to be sine square x plus cosine square x minus sine x cosine x. And finally, I get to replace that sine square x plus cosine square x with just a 1. And there it is, 1 minus sine x cosine x. And that's it, we're done. Okay, so let me just review this problem with you guys. The first step is just to apply this identity from algebra, the sum of cubics. Okay, that's the first step. Once I apply that, I get to cancel out the common factor on top and bottom, and that's the sine x plus cosine x, and that's just another algebraic step. You can cancel out common factor on top and bottom. So first step is algebra, factoring. Second step is algebra, factoring as well. And once you cancel that out, you get this guy. Third step is, well, this is just another version of this guy, so it's not really a step. The third step is just a rearrangement of all these terms. So I arranged the term so that the cosine square is right next to the sine square, because then I get to see, I get to use the Pythagorean identity. Sine squared x plus cosine squared x is simply a 1. And so it's going to be a 1 minus sine x cosine x. And that is exactly the right-hand side. Okay? And we're done. Okay, so I'll be posting up the notes for section 7.2 very soon. Thank you.